Right, this is question number 1. The probability distribution of a discrete random variable x is given by the following table where n and p are constants. Find the value of p. Okay, so all the probabilities must add up to 1. Here we can look at these as decimals. 1/2 is 0.5, 1/5 is 0.2. So clearly the value of p must be 0.1. Okay, so for letter A, p is equal to 0.1. Another way of looking at this question is changing all the fractions into fractions with the same denominator. In this case 10, so 1/2 is the same as 5/10. This is 2/10, 2/10, then this is 1/10. Given that the expected value of x is equal to 10, find the value of n. The expected value of x is this times this plus this times this plus this times this plus this times this. So 1 times 1/2 plus 5 times 1/5 plus 10 times 1/5 plus n times 1/10. This must be equal to 10. 1 times half is half, or 0.5, plus 5 times 1/5, which is 1, plus 10 times 1/5, which is 2, plus 0.1 n. This must be equal to 10. 2 plus 1, 3, 3 plus half, 3.5, plus 0.1 n must be equal to 10. Then 0.1 n is equal to 6.5. Then n is equal to 6.5 divided by 0.1. Dividing by 0.1 is the same as multiplying by 10, or if you multiply both by 10, you get 65 over 1, which is equal to 65. So n is 65. Here in this question, first thing to know is that the integral of e to the 2x is e to the 2x over 2. From 0 to ln k, this must be equal to 12. Then substituting limits, e to the 2 ln k over 2 minus e to the 2 times 0 over 2. This must be equal to 12. We can multiply the whole equation by 2. E to the 2 ln k minus e to the 0 is equal to 1. So 1 equals 24. Then e to the 2 ln k is equal to 25. Here we can say that 2 ln k is equal to ln 25. The reason for this is that we can apply ln to both sides of this equation. Equals ln 25. And then when you do ln of the exponential, these things cancel out because the 2 ln k come here to the front. ln 1 is e, so that's why we get 2 ln k equals ln 25. Ln k squared is equal to ln 25. Then k squared is equal to 25. Here k could be either 5 or minus 5. Then if we go back to the original question, we have ln k, so k cannot be negative. That's why the question says find the value of k, not the values of k. Then the only answer that is possible here is the answer k equals 5. For this question, I'm going to use row operations. First, we do 2 minus 1, 1, 5, 1, 3 minus 1, and 4, 3 minus 5, A and B. First thing that I would do here is change these two rows. This will make the calculations easier. Then 2 minus 1, 1, 5, 3 minus 5, A and B. Now we're going to make these two values become 0. To do that, this row, which is row number 2, is going to become 2 row 1 minus row 2. And for this number to be 0, we're going to get this first row, multiply by 3, then subtract row 3. So row 3 is going to be substituted by 3 times row 1 minus row 3. So the first line we just repeat. The second line, multiply this by 2, subtract this one. 2 times 2, 2 minus 2, 0. 2 times 2, 2 times 3, 6, 6 minus 1, 7. 2 times minus 1, minus 2, minus 2, minus 1, minus 3. 2 times 4, 8, 8 minus 5, 3. Now row 3, 3 times row 1 minus row 3. 3 times 3, 3 minus 3, 0. 3 times 3, 9, 9 minus 5, 14. 3 times minus 1, minus 3, minus 3, minus 8, minus 3, minus 8. And 3 times 4, 12, 12 minus b, 12 minus b. Okay, now we have to make this number become 0, and that's simple because as this is 7, we can get the row 3 and substitute row 3 by 2 times row 2 minus row 3. So I'm going to repeat the first line, the second, minus 3, 3. So 2 times 7, 14. 14 minus 14, 0. 2 times minus 3, minus 6. Minus 6 minus 3 minus 8 is going to be minus 3 plus 8. And 2 times 3, 6. 6 minus 12 minus 6 plus b. Okay, now that we get this point, and we want, according to the question, we want the points to have no point of intersection, so it's necessary this number here must be 0, and at the same time this number here cannot be 0. Then minus 3 plus a must be equal to 0, a must be equal to 3, and minus 6 plus b cannot be 0, and then b must be different from 6. These are the set of values for a and b, so that the planes have no point of intersection. To solve this question, we need to get this expression and use compound angle identities. In this case, we're going to use cos A plus B equals cos A cos B minus sin A sin B. And here we can write that cos 2A plus B is going to be equal to cos 2A cos B minus sin 2A sin B. We need to find cos 2A. To find cos 2A, I'm going to use double angle identity. Cos 2A, there are 3 ways to find. In this case, we're going to use this one because we have the value of cos A. Then cos 2A is 2 cos squared a minus 1, which in this case is 2 squared minus 1, and 2 times 2/3, which is 4 over 9, 8 over 9, 8 over 9 minus 1, minus 1 over 9. This is the value of cos 2a. We're going to need this to substitute in this expression. We don't have cos b, but we can find cos b because we have sin b. This can be done because we can use the Pythagorean identity, the most important one. So cos squared b plus sin squared b must be equal to 1. Cos squared b plus 1/3 squared is 1 over 9 is equal to 1. Cos squared b is equal to 1 minus 1 over 9, which is 8 over 9. And then cos b would be plus or minus the square root of 8 over 9. But as the angles are cubed, we're going to consider the positive value. Square root 8 is 2 root 2. Square root 9 is 3. So we have cos b and sin 2a now. We don't have the value of sin 2a. We have sin b, so if we find sin 2a, then we can find the answer. Sin 2a using another double angle identity, this time for sin 2 theta. Sin 2 theta equals 2 sin theta cos theta. 2 sin a cos a. We don't have sin a, we have cos a. Again, sin squared a plus cos squared a is equal to 1. Sin squared a plus 2/3 squared is equal to 1. Sin squared a is equal to 4 over 9. 1 minus 4 over 9 is 5 over 9. Then sin a again is going to be the positive value, root 5 over 3. So sin 2a is equal to 2 sin a, which is root 5 over 3, times cos a, which is 2/3, and then this is equal to 4 root 5 over 9. Finally, we can find cos 2a plus b, which is cos 2a. What is cos 2a? Minus 1 over 9 times cos b, which is 2 root 2 over 3, minus sin 2a, 4 root 5 over 9, times sin b, which is 1/3, and then minus 2 root 2 over 27, minus 4 root 5 over 27. That's the final answer. That's what we need to show. Okay, so first, minus 4 represented on an Argand diagram is this here, modulus 4, argument pi. Then, if now we want to solve this equation, it's the same as solving this equation here, and then we can find the solutions in the form, let's say, fourth root of 4, 6 pi plus 2k pi over 4, where k is 0, 1, 2, 3. So the solutions, Z1, the first, is going to be square root 2. Fourth root of 4 is the same as square root 2. And then when k is 0, this is 6 pi over 4. That's the first, which is the same as root 2 cos pi over 4 plus I sine pi over 4. Root 2 cos pi over 4 root 2 over 2 sine pi over 4 root 2 over 2 as well. So when we expand, this becomes 1 plus I. If we were to represent this on a Hagen diagram, that's the first solution, then we would find the following. Pi over 4, which is the same as 45 degrees. This is root 2. And then the other solutions are going to be equally spaced here. So we go to this side here. So all these lengths are going to be root 2. And these 4 points are going to be the roots. Okay, so this here is 1 plus I. Then this one is minus 1 plus I, minus 1 minus I, and 1 minus I. These are the 4 solutions. Okay. To answer letter B, we must note that this is a square. Okay. Polygon formed by the 4 solutions is a square that has diagonal 2 root 2. Okay, so if you have a square that has diagonal 2 root 2, then the side of the square is 2. So the area of the square is 4. So in mathematical induction, the first step is to prove that P1 is true. In this case, we need to do, let's check first P1. Let's do the first derivative of this. We need to use product rule. Derivative of x is 1 times e to the 2x plus x times the derivative of e to the 2x, which is 2e to the 2x. If we factorize e to the 2x, we have 1 plus 2x. That's what we find by using the product rule. So let's check if the formula gives the same. So now using the formula, first derivative is going to be 2 to the power of 1, as in this case n is 1, x plus 1 times 2 to the power of 1 minus 1 e to the 2x. 2 to the power of 1 is 2, 2x plus 2 to the power of 0 is 1 times 1 gives 1. So this is e to the 2x. And then it's true, both are the same, P1 is true. Now let's do the next step. The next step is assume that pk is true, where k is any number bigger than 1. Okay, so we say that fk is 2 to the k x plus k 2 to the k minus 1 e to the 2x, and our aim is to show that pk plus 1 is true. So if we have fk, which is pk, to find pk plus 1 we have to do the derivative of this. So the derivative of f of order k is f of order k plus 1. We have to use product rule here. Okay, so the derivative of this is just 2 to the k, because this is a constant value. The derivative of a constant value is 0, so this is 2 to the k times e to the 2x plus this thing here plus k 2 to the k minus 1 times the derivative of e to the 2x, which is 2e to the 2x. Let's write now the common factors. E to the 2x is the common factor, so e to the 2x 2 to the k plus 2 to the kx plus k 2 to the k minus 1. This is equal to e to the 2x 2 to the k plus, when you multiply 2 to the k plus 1 x plus, when you multiply 2 by 2 to the k minus 1 becomes 2 to the k, so k 2 to the k, e 2 to the x, and then this and this, they have a common factor which is 2k, then 2k 2 to the k plus 1 plus 2 to the k plus 1 x. Then we did it because this expression for k plus 1 is the same as this expression for k. The only difference is that rather than having k, we have k plus 1. So e to the 2x is here, then it's here, e to the 2x. We have this 2 to the k became 2 to the k plus 1 x, and this k became k plus 1, k minus 1 became k. So with this we say that pk plus 1 is true. And then the final conclusion of the induction is P1 is true when Pk is true. Pk plus 1 is true. So that's what we have shown. So with that, Pn is true for all n, in this case, this. Okay, trig 2x minus x squared. First, I would write as minus x squared plus 2x, then write as minus, open brackets, x squared minus 2x. Completing these squares, minus x squared minus 2x plus 1 to make a complete square, but then subtract 1. This part is x minus 1 squared minus 1, and then if we remove brackets, minus x minus 1 squared plus 1. This is the answer for letter A. So to do letter B, we can write the integral from 1/2 to 3/2 as 1 over. I'm going to write this expression, but on the other way around. So square root to 1 minus x minus 1 squared dx. Now I'm going to do substitution. U equals x minus 1. As the derivative in this case is 1, then du is equal to dx. And then this gonna be from the integral. Let's change the limits. When x is half, u is gonna be half minus 1, which is minus half. When x is 3/2 minus 1 is 1/2. 1 over square root of 1 minus u squared du. If we look at the formula booklet, in the part of derivatives, the derivative of arc sine x, 1 over square root of 1 minus x squared, so the integral of this is arc sine x. So this is going to be arc sine u from minus half to half, and this is going to be equal to arc sine half minus arc sine minus half. Arc sine half is 30 degrees of pi over 6. In this case, we must use pi over 6. And arc sine of minus half minus pi over 6. Pi over 6 plus pi over 6, which is equal to 2 pi over 6 pi over 3. In this question, we need to observe that the plane pi, which is this, is a plane that is normal to the x-axis. So a normal vector would be 1, 0, 0, or any other multiple of this, but we are using 1, 0, 0. Also, we must remember that the special case of finding the angle between the plane and a line. That's the angle we want to find. But then what we do, we find the angle between the normal vector of the plane and the direction vector of the line. And then we do 90 degrees minus this angle. That's what we're going to do. Okay, so the direction vector is this. This is the direction vector of the line. Is in terms of theta. And then we're going to do the angle using the formula for the angle between two vectors. Scalar product of the two vectors, and then here the magnitudes of the two vectors, and then when we do here the scalar product, 1 times 5 gives 5, plus 0 plus 0, this is equal to 1, and here cos squared plus sine squared is also equal to 1, add to 25 becomes 26, so cos alpha is 5 over square root 26. But then we found this angle here, and we want to find this. As cos alpha is 5 over square root 16, square root 26, sorry, alpha is the arc cosine, that's a value that if we could use the calculator would tell us, but we don't have this here. So the angle that we want to find is pi over 2 minus alpha, which is pi over 2 minus, that's the angle we want to find. So this value is the same value for any value of theta and for any value of p. So that's why it's independent of p and theta. Okay, so the angle 105 is this angle, is 75 degrees from this part. So if this part here, this is Q, which is cos 75, then cos G 105 is exactly the same length, but on the negative side, that's minus Q. It's important to know that cosine G 180 minus x is minus cos x. So cos G 180 minus 75 is minus cos 75, which is minus Q in this case. This is cos 105. So you can either do this or this to show that the cosine of 105 is minus Q. Then let's move to letter B. Okay, you must show that BAD is equal to 75. So what we're gonna do, this side is equal to this side. So this is 9 degrees, this is 45, and this is 45. So we must find this angle now. So this is R, which is the radius of the circle. This is also the radius, this is also the radius. So this side is 2R. Okay, so let's say that this angle here is the angle theta. We can say, for example, that sine theta is the opposite, which is R, divided by the hypotenuse, which is 2R. So it's half, and the angle that has sine half is 30 degrees. Okay, so in fact this angle theta is 30 degrees. That's why BAD is equal to 75. By considering triangle ABD, show that BD squared is equal to 5r squared minus 2r squared cubed root 6. So let's find an expression for this. Okay, so we can use Pythagoras in this triangle. BA squared plus r squared equals 2r squared. So BA squared is equal to 4r squared minus r squared. BA squared is 3r squared. So BA is r root 3. Now let's find AD, which is the same as DC. And again, I'm going to use Pythagoras in this triangle. AD squared plus AD squared is equal to 4r squared, which is 2r squared. And then 2AD squared is equal to 4r squared. AD squared is equal to 2r squared. AD is r root 2. So this is r root 3, and this is r root 2. So now using the cosine rule in this triangle for BD, we can say that BD squared is equal to r root 3 squared plus r root 2 squared minus 2r root 3 r root 2 cos 75 degrees. BD squared is equal to 3r squared plus 2r squared minus 2 root 6 root 3 times root 2 root 6 r squared, and then cos q is cos 75 is equal to q that was given in the beginning of the question. So combining these two terms, BD squared is equal to 5r squared minus 2 root 6 r squared cubed. Okay, by considering triangle CBD, find another expression for BD squared in terms of r and q. So we are going to look at this triangle now. This is r. Here is r square root 2. This is also r square root 2. Then let's do it. This angle is 60 degrees because these three angles must add up to 180. So the other expression we're going to write for BD using this triangle now. BD squared is equal to r squared plus r root 2 squared minus 2r r square root 2 cos of 105. BD squared is going to be r squared plus 2r squared minus 2 root 2 r squared. Cos 105 is minus q. Then BD squared is going to be 3r squared plus 2 square root 2 r squared cubed. And then the last thing we are asked to do is to use your answers to part C to show that cos 75 is equal to this. And then we are going to use the two expressions, the first and the second, and equate them. So in letter D, we found first 5r squared minus 2r squared cubed root 6 is equal to 3r squared plus 2 root 2 r squared q. So let's solve for q. First, we note that all the terms they have r squared, so we can divide the whole equation by r squared. So 5 minus 2 root 6q is equal to 3 plus 2 root 2q, and 5 minus 3 is equal to 2 root 6 plus 2 root 2q. So what is q? Q is going to be 2 over 2 root 6 plus 2 root 2, and then if we divide both numerator and denominator by 2, we get 1 over square root 6 plus square root 2, and q is exactly cos 75, so that's why cos 75 is 1 over root 6 plus root 2. In this question, to do the derivative, we must use the quotient rule. Apply the quotient rule to the function f. The derivative is derivative of 2x minus 4, which is 2 times x squared minus 1, minus derivative of x squared minus 1, 2x times 2x minus 4 over x squared minus 1 squared. Simplifying, f dash equals 2x squared minus 2 minus 4x squared plus 8x over x squared minus 1 squared. Collecting like terms, minus 2x squared plus 8x minus 2 over x squared minus 1 squared. That's the answer for part A1. To do part A2, so this is A1. Part A2, we must equate the derivative to 0. So when we do the derivative equal to 0, we have to solve, in fact, this equation. Minus 2 is equal to 0. It's a quadratic equation. To solve this quadratic equation, first, simplify the equation by dividing the equation by minus 2. X squared minus 4x plus 1 equal to 0. Using the quadratic formula, x equals minus b, so 4 plus or minus b squared, the square of minus 4 is 16, minus 4 times a times c. Both a and c are 1, so 4 over 2a, 2 times 1, which is 2. X is 4 plus or minus root 12 over 2. X is equal to 4 plus or minus 2 root 3 over 2. And then if we simplify by 2, x is equal to 2 plus or minus root 3. We will consider only the solution x equals 2 minus root 3. The only solution is valid because the domain of the function is between minus 1 and 1. Okay. To find the y-intercept when x is 0, we have y equals 2 times 0 minus 4 over 0 squared minus 1, which is minus 4 over minus 1, which is 4. So the y-intercept is at 0, 4. To find the x-intercept, then we would have to do y is 0. When y is 0, then 2x minus 4 over x squared minus 1 is equal to 0. So the numerator has to be 0, and then x would have to be 2. But then 2 is not in the domain of the function. So that's why we have no x-intercept. Okay. So, looking at the expression of the function, it's possible to see that we have two vertical asymptotes at x equals 1, x equals minus 1. Okay, so we have a vertical asymptote here, a vertical asymptote here. The y-intercept is at 0, 4. So let's say 4 is here. And then, as the function has no x-intercept, the whole of the function is above the x-axis. And then, as we have the first derivative equal to 0 at 2 minus root 3, which is about 0.27, let's say more or less here. So here we would have a minimum. So we have an asymptote here, and we have this. Change the minimum a bit, and then that will be, the minimum is here, and this is the point, 0, 4, and that's the sketch. For letter C, the common denominator is x plus 1, x minus 1. Then we do 3, x minus 1 minus 1 times x plus 1. Expanding 3x minus 3 minus x minus 1 over x squared minus 1. Then 2x minus 4 over x squared minus 1. And this is a sketch of the situation letter D. This is the area we have to find. So we need to find this point, which we already know, which is 0, 4, and these are the point here. So to find this point, we must find the point of intersection of 2x minus 4 over x squared minus 1 and the line y equals 4, so equals 4. Solving this equation, cross multiplying 4x squared minus 4 equals 2x minus 4. Subtracting minus 4 from both sides, 4x squared minus 2x is equal to 0. Dividing the whole equation by 2, 2x squared minus x is equal to 0. Solve by factorizing x, 2x minus 1 is equal to 0. Two solutions are x equals 0, the one we already knew, and 2x minus 1 is equal to 0, means that x is equal to half. Now that we have this information, we know that this is half and here is 0. The area of the region is the integral of the function which is above, 4, minus the function which is in the bottom, which is this, which can be written like this. To do the integration is better use this form. So the area is the integral from 0 to half, 4 minus 3 over x plus 1 minus 1 over x minus 1, this whole expression dx. This integral is simple. Integral of 4, 4x. Integral of 3 over x plus 1 is minus 3 ln absolute value of x plus 1 plus ln x minus 1, using the limits from 0 to half. Area is, substituting half, it's going to be 4 times half minus 3 ln half plus 1 plus ln half minus 1 minus, if we put 0 in all these expressions, they all become 0 because ln 1 is 0, so minus 0. So a is equal to 2 minus 3 ln 3 halves plus ln, the absolute value of minus half is half, ln half a is equal to 2, the same as ln e squared minus 3 ln 3 minus ln 2 minus ln 2. So ln 3 over 2 is the same as ln 3 minus ln 2, and ln half is the same as 2 to the minus 1. That's why it becomes minus ln 2. A is equal to ln a squared minus 3 ln 3 plus 3 ln 2 minus ln 2. Combining these two terms, we get ln e squared minus 3 ln 3 plus 2 ln 2. And a is equal to ln e squared minus ln 27 plus ln 4. A is equal to, putting these two together, ln e squared over 27 plus ln 4, which is the same as ln 4e squared over 27, and that's v. Okay, we need to find first the vector AB, which is OB minus OA. In this case, OB is 0, 10, 0. The vector OA is the vector 0, 0, 10. So AB is 0 minus 0, 0, 10 minus 0, 10, 0 minus 10, minus 10. We also need to find the vector AV. AV is OV minus OA. OV is P, P, P minus OA. OA is 0, 0, 10. So AV is P, P, P minus 10. Now that we have these two vectors, we can do the vector product AB, AV. So AB, vector product AV is 0, 10 minus 10 cross P, P, P minus 10. From the formula booklet, there's a formula. Formula is this formula here. Okay, so 10 times P minus 10 minus minus 10p, so plus 10p. The second coordinate minus 10p, then minus 0, so minus 10p. And the last coordinate 0 times p, which is 0, minus 10, so minus 10p. If we simplify this expression, this is going to be 10p minus 100 plus 10p minus 10p minus 10p, and this is 20p minus 100 minus 10p minus 10p. Okay, so we can write minus 10 as a common factor, so that we get the answer in the way we want. So if we make minus 10 a common factor, then we will have minus 2p plus 10 p and p. AC is OC, which is 10, 0, 0, minus OA, 0, 0, 10. This is 10, 0, minus 10. Now AV is the same AV that we found before. Okay, so this is gonna be V P P P minus A 0, 0, 10. Again, it is P P P minus 10. Cross product AC AV is 10, 0, minus 10 cross P P P minus 10. We start with 0 times 10 times P minus 10, which is 0, minus 10P, so 10P. Then for the second coordinate, we do minus 10P minus 10P minus 10. And for the last coordinate, 10 times P, 10P, minus 0. So that's the vector. Simplifying, it's going to be 10P minus 10P minus 10P plus 100, 10P. It is 10P minus 20P plus 100, 10P. If we write minus 10 as a common factor, minus 10, then we will have minus P, 2P minus 10, and minus P. This could also be written as 10 P minus 2P plus 10 P. Both ways will work. We're going to use this. To find the angle between the faces ABV, ACV, we note that this product, this vector, is a normal vector to the face ABV, and this is a normal vector to ACV. So we need to find the angle between these two vectors. No need to use distance, so we're using here the vector without the 10, but keeping the negative. Is going to be 2P minus 10 minus P minus P, and here P minus 2P plus 10 P. I'm going to find the angle between these two vectors. Cos theta is 2P minus 10 minus P minus P, scalar product P minus 2P plus 10 P over the magnitudes. The magnitudes 2P minus 10 squared plus P squared plus P squared. The magnitude of the other vector is P squared plus minus 2P plus 10 squared plus P squared. Cos theta is equal to, on the numerator, let's expand 2P squared minus 10P plus 2P squared minus 10P minus P squared. The denominator, the two magnitudes, in fact, are the same. So when we multiply the roots cancel out. So we are left with 2P squared plus 2p minus 10 squared cos theta is 2 plus 2, 4, minus 1, 3p squared minus 20p on the denominator 2p squared plus 4p squared minus 40p plus 100, and then cos theta is equal to 3p squared minus 20p over 6p squared minus 40p plus 100. Factorizing the numerator p, 3p minus 20. The denominator is the same, 6p squared minus 40p plus 100. ABV and ACV are perpendicular, therefore the scalar product must be 0. The angle has a cosine which is 0. So p, 3p minus 20 must be equal to 0. So either p 0 or 3p minus 20 is equal to 0. So p is 20/3. Comment on the positions of v in relation to the plane ABC. Yeah, it's the plane ABC. When p is 0, the point is the origin. It's kind of behind the plane. And when p is 20/3, the point has coordinates 20/3, 20/3, 20/3, and it's here in the front of this plane. So the conclusion or the comment they expect us to do is to say that the 2 points, so the points are 0, 0, 0, and 20/3, 20/3, 20/3, because in the beginning the point is the form PPP. So these points are on opposite sides of plane ABC. To find the maximum of the graph shown in the question, we write theta as a cosine, this expression, and then to find the maximum in this case, we need to remember that a cosine has a maximum when x is minus 1. Okay, so we need this to be minus 1. When this expression is minus 1, this will give the maximum value. So we equate p, 3p minus 20 over 6p squared minus 40p plus 100 to minus 1. Then we expand 3p squared minus 20p equals minus 6p squared plus 40p minus 100. 9p squared minus 60p plus 100 is equal to 0. It's a quadratic. We will factorize. The sum is minus 60. The product is 900. Not difficult to find. The numbers are minus 30 and minus 30. So 9p squared minus 30p minus 30p plus 100 is equal to 0. 3p 3p open brackets, 3p minus 10 minus 10, 3p minus 10 is equal to 0. So what we get in fact is 3p minus 10 squared is equal to 0. This means that p is equal to 10/3. So when p is equal to 10/3, the angle theta is pi, which is the maximum value that we found before. So to understand what is the horizontal asymptote, we need to find the value of cos theta when p gets very large. When p gets very large, this is kind of the limit of this expression when p goes to infinity. So as p goes to infinity, so this expression will go to 3/6. So cos theta is going to get closer and closer to 3/6, which is a half. And the angle that has cosine half is the angle 6 degrees, which in radians is pi/3. So that is the equation of the horizontal asymptote.